You can just click on that. That should open up a page look like this. Should work without any problem any web browser. And the option you need is actually the third option called the lab. If you click on that, this should open up. Now, technically, it doesn't matter which option you click because when you come here in this page, you can actually change the option again if you want to. Okay, you can see very below there's 4 different options. So the option we're going to be using option called lab. Okay. And then in the middle, you will see a page look like the regular graph sheet. And then there's a 2 axes, horizontal X, vertical Y. And then this is the origin point. If you bring your cursor on top of the origin, and then you can see the cursor is changed its shape, and then you can click and drag wherever you want your axis system origin to be. Because we have to have a space accordingly as we continue on the drawings in a bit. So you may have to change that origin position, okay? And on your right hand side, you will see a couple of options. These are the vectors we needing, and then I will explain you in a bit, okay? Question. All right, so let's take a look what we trying to do in this lab. So the idea is actually try to find the resultant vector. Now you know resultant vector mean if you have two vectors, if those two vectors added on top of each other, then we can find the resultant. And then when it comes to vector addition, there are a couple of different techniques, right? One we call the graphical method. We did not discuss too much that in the lecture class because that is not our primary focus on the lecture class, but that is one primary focus in today's experiment. So we're going to take a look very in detail how can we add vectors by using graphically. Graphically mean by just drawing the vectors on a graph sheet by using the arrows. Okay, that's the plan. And then second half of the lab, we're going to do calculation by using the same technique we use in our lecture class, the component method, and also the sine cosine rule. So the first table on your data sheet is about our experiment, that is the drawing method called the graphical method. We're going to take a look two different graphical method, and since we use in the simulator, this is going to be very perfectly match these two. But if you use the in-class method, then you will see some sort of percent error always associated with them. And then table number 2 is the analytical method that is actually useful to improve that knowledge you may need it actually in coming exam too, okay? How to do the vector addition method by using the component that we're gonna do again. And then last table is the percentage difference comparing what you calculated on table number 1 and table number 2. So please, you need to actually rechange the table name right here. You see table number 1 has the result of vector addition by graphical method. I actually mistakenly same term. So you have to really change that. Second should be table number 2. Please change that if you see the same name, result of the vector addition by using analytical methods. Analytical methods. Change that, and the table number 3 looks, I think, fine. Yeah, table number 3 looks fine. Yeah, that's a comparison of the resultant vector from the previous two, okay? All right, so let's take a look how we're gonna add two vectors. Anybody have any problem with the simulator or anything?
How do I get to that again? I'm sorry.
Say it again.
I haven't gotten onto the simulator. I'm on the link.
Say it again. What's your question?
Do I just have to hit the lab button?
Okay, so you go into lab manual and then go to page number 3, then you have a link.
Yep, I'm on that link.
Then click that. Link will not automatically open for you, right? Unless you click that.
Right, but once I get to the four options, which one do I go to?
You have three options down here. You can see.
Okay, so I just go
Click
to the lab.
click on the lab. You see that highlighted. Okay, click on that.
Okay, I'm good.
Okay, so anyone else has any problem with the simulator? All right, then let's continue. Now the idea is adding two vectors. We're going to try three different vector addition. Okay, case one, we're going to add two vectors. Case two, we're going to add three vectors. Case three, we're going to add four vectors together. Okay, that's the plan. Case one. So I have to add two vectors. Our two vectors are for case one is actually these two vectors. Vector number one, 8.60 Newton, and then theta 1 is 35.5. Now, when it comes to this drawing method, I need to have some sort of unit conversion. So which means now you can see vector is given in unit Newton, but you can't draw unit Newton here. So the plan is that each 1 Newton, I'm going to assume one of these is square shape right here is small square, that is 1 Newton in our plane, right? So which means when I drawing the vector here, 5 of a small square length is actually represent 5 Newton and then so on, okay? So that's our unit conversion from Newton to our graph sheet. Now, since we're doing it here, it is actually much easier. All we have to do is click this blue arrow and then bring it here. We're going to try the method one called the tail to head method first, okay? Method one, graphical method, tail to head. Bring the arrow, start from the origin, and then arrow head, we need to change. We need to find the angle 35.5, and also we have to find the magnitude 8.6. Now, if you draw this in class, what we're going to do, you're going to bring a protractor and then place it here, and then identify the direction of 35.5 first, then bring a meter ruler and then draw a line with the size of 8.6 centimeters so that we can assume 8.6 in Newton magnitude. Now, since simulator, we can't do that, all those work. Actually, this is much easier. All you have to do, click on this arrowhead and then change the arrowhead until you see 8.C on top of here. That's the magnitude, and the angle 35.5. And you can see the projection also, it's showing for you automatically. What's the X projection, what's the Y projection? Those are the component. And also if you click on right hand side very top, this icon that will show you the angle, and the next icon values that will show you the magnitude. It's very much easier with the simulator than the drawing. Okay, question. All right, then now the tail to head method, if I want to draw the second vector must start from the end of the first vector. Okay, so that means the tail of this vector should be at end of the first vector right here. Then I have to click the arrowhead and then rotate and then figure out direction. I need 160 degrees from positive x-axis and then 11.7 in magnitude. So I need to search that where the exact location is 160 degrees in magnitude from x-axis, and the 186 degrees on from x-axis, and the magnitude 11.7. Now, if you're drawing in a paper, then you have to first draw this horizontal line here, and then bring a protractor, identify this angle, and then bring a meter ruler, and then draw that line with 11.7 centimeters. Then you have that vector. Question. Okay, now this is so easy than you drawing on the paper. If you want to draw this on the paper, that's going to take a lot of time, okay, than this one. Okay, Now what we need is a sum, right? So the addition of two vectors, should start from here, from the origin, go all the way to there. That should be the result. And now in the simulator, we can check that easily. Click on the sum here, only blue line, okay? Very top right hand side, it says sum. Click on that. And then the new vector appear, new arrow appear. That must be our resultant vector. Now the magnitude 9.8, direction 114. Now we need to check that whether that is our resultant vector. Then all you have to do, click and drag, and then see whether you can connect that gap right here exactly with that solid dark blue line. If that is the case, which means that is of course the resultant vector. Okay, question. Okay, so that easy actually, nothing much to do in that case. So all you have to do now, write it down, the resultant vector we observe here. So what we observing resultant vector is 9.8 unit Newton, and the angle theta is 114 unit degrees, right? Unit degrees, you can't just type there. So you can insert that icons, insert in symbols, right hand side very top. If you click the symbols again, you will see this new window will appear. And then if you select the subject right here, Latin 1 supplement, then you will see a degree symbol very right hand side top corner. Then if you insert that, that degree symbol goes to there, okay? And then make sure you can actually make all of the center. Those things are very simple, formatting center and then center. Then it looks nice on your table. Now, if you're doing this in class, then you have to really measure this line, okay? You have to measure that in magnitude by using meter ruler, and also you have to measure the angle by using the protractor. But this is much, much easier than that. Okay, that is our graphical method one. Very simple. Question. Okay, then let's do graphical method two. Graphical method two called the parallelogram method. Actually, it's not a new method. You will see in a bit. Parallelogram method is actually a same kind of tail to head method, but it's a different version of that. Actually, tail to head method is actually inside the parallelogram method automatically after we draw. Now, all of these diagram are your real diagram. Now, in this lab, when you're making the report, there's no graphs, right? All of these tree data table must be there, and these drawings which we're making here, these are actually your real data. So you need to use only one picture on your procedure section, that is your simulator picture. But all of these real drawings should go into actually data section. Okay, this is not like the other labs which we done. In other labs, there's no really simulator. We actually making many pictures, but today we're going to make at least 6 different pictures. Okay, so all those pictures are actually part of your data. Now let's take a screenshot. First screenshot should go to here. You can see I put only 2 spaces, but there should be 6. Okay, these 2 only for case number 1. Case number 2 has another 2. Case number 3 has another 2. Insert the picture here. Insert pictures, your left hand side very top. And let's select the pictures, screenshot. And then if there's extra information, you can crop that out. Click on the picture, then double click on the picture, and the right hand side very top you will see a crop. Then you can crop that out. Okay, there's various methods to do this thing. So and then crop that out to only graph sheet. That's only we need to show. We don't need to show anything else on that page. Okay, so that's the only part we interested. That's our figure number 1, but this figure is real data, okay? You can attach only attach one figure into the procedure section because you have to write the procedure, how you do this drawing and then so on. And then there's two way actually you can do. You can actually put all those figures into procedure and then explain how you done the graphical method. And then in the discussion section, you can call that one way you can do. Other way is that you can do one picture there, explain everything. All the other diagrams you can put under the data section. That also fine for this experiment, okay? All right, let's draw next diagram. To draw that, you have to get rid of all here. To do that, you can click this yellow color circle right here on the bottom. You click that once, everything disappears, everything reset. We can click this origin location into a different place because we would like to see our diagram in the middle of the graph, right? Now, only difference between, anybody have any question? Okay, now the difference between the previous method and this method is actually next method called the parallelogram. Only difference is that all the vectors must start from the origin. That's the difference, okay? Tail to head method, second vector must start end of the first vector, but the parallelogram, all the vectors must start from the origin. That's the difference. Okay, now let's draw first vector. Arrow number 1, you have to click the head and then change the arrow position until you see angle 35, magnitude 8.6. And then you bring the second vector. Now the second vector has to again start from the origin. And then you have to change the arrow head until you see 160, and then magnitude is 11.7. If you can't figure that out, easiest way is that you can go back and then take a look the previous diagram that already have that. See that already have the variation, then you can easily identify how big that vector should be, okay? Nine 9.8 and 160. Let's see where it should be. 9.8, I can get there. You need to take a look, just carefully adjust a little bit, then you can find exact location, okay? 160 and 11.7, okay, good. 160 and 11.7. So the coordinate wise, your arrowhead should be on x-axis negative 11, y-axis positive 4. That way the coordinate wise arrowhead should be, okay? All right, now how to make the parallelogram. Parallelogram is actually a small diagram, how it should be look like. It should have to have two parallel lines connecting together, right? So parallelogram should contain two parallel lines. So which mean I have to make a parallel line to this vectors which passing through this endpoint right here. So let's make that by using the different color. I have to have a parallel line right here, which should be exactly similar to the vector number 2. Exactly similar to the vector number 2, okay? It's easier actually if you bring that vector here and then exactly find where it should be, then click and drag and then leave it there. So now this orange color line is actually parallel to this blue line right here, vector number 2. Now parallelogram should contain 2 of parallel line, right? So which means I have to have another parallel line which should be exactly parallel to your previous vector, and then it should pass through other end of the vector number 2. That means right here. Now you can see this is a parallelogram which has 2 parallel lines connected together, so which creates the closed loop. So that's a parallelogram. That's the only difference compared to previous, okay? Now our real vectors, we consider these only blue ones, right? So which means to find the resultant, you click the sum again here. Now in the parallelogram method, if you draw a parallelogram which have 2 vectors known, and the resultant of those 2 vectors should be given by the diagonal right here. Diagonal is starting from the origin, go all the way to the other end of the parallelogram, which means I can check that by bringing this line right here. If you bring that and then try to put exactly on the diagonal, then you can see that is exactly fit with the diagonal space. So that is actually the resultant vector of these two. So which means that's why I earlier mentioned there's no big difference between these two methods. The parallelogram method is actually included the tail-to-head method some way. It's not anything new or anything completely different, but the when you draw the parallelogram method, you can do only for 2 vectors. That's the other thing. You can't do this for more than 2 vectors. But the previous method, tail-to-head method, you can do for many vectors. You can do for 2, 3, 4, 5, 10, any number of vectors. You will see in a bit when we do the next 2 part. Okay. Question. Now the resultant is not any change at all. So you can put the numbers here, 9.8 Newton and then 114 degrees. I'm just going to copy paste this one here. It's the same thing. There's no difference at all. Okay, let's take a screenshot of our parallelogram. And then let's add the parallelogram into our second location of the picture here. Insert second picture. Anybody have any question? Screenshot parallelogram, and then you have to crop that out. The information which we don't need. Just need the graph sheet only, okay, not anything else. Right, so that is our second diagram with addition with the parallelogram method. Now we can take a look what we're going to do if we have more than 2 vectors. Okay, so that case number 2 question. Any question? Okay, then let's continue to next diagram. So I'm going to get rid of this diagram. So if you click this yellow button right here, right hand side very bottom, it can reset everything. Then let's bring this origin into a different location, because you can see third vector, the second case, I have first 2 vectors same, one in first quadrant, second in second quadrant, but the third in third quadrant, which means I may need this space right here. Okay, that's why. So let's bring some space there. Now let's draw the 3 vectors. Now tail to head method, go one after the other. So which means first vector 8.6 and the degree 35.5 angle. You just need to click the head and then change where it's supposed to go until you see the numbers are matched with the given numbers. Okay. Then in the tail to head method, after the first vector, end of the first vector, you're going to start the second vector and then change the direction by click and drag the arrow head until you see 160 and 11.7. Okay, 160 and 11.7. That is our second vector. If we have only two vectors, resultant should be this space right here. But now I have a third vector, so which means that should go end of the second vector. So let's bring the third vector, end of the second vector. It started there, and then I have to change the direction of that vector. If you take a look, the direction 234.0. So that means that should go to the third quadrant. Now, when you take into the third quadrant, you can see there is a problem in the simulator, because simulator measuring the angle always 0 to 180, but anything beyond that, it doesn't like to measure directly, right? Instead of that, what it gives you as a negative angle. So which means I need to find what is the negative angle to represent 234. So to find that, you have to do just subtract 360 by 234. Then you will get the negative angle. Okay. So let's first do that. You can do it on your Excel sheet if you want to. Otherwise, you can just check that number. So 234 minus 360. That should be our negative angle. If you put equal sign, that will give you the number what we're looking into, 126. Let me write it down that here, 234 angle, which is equal to minus 126 degree angle 2. Okay, so that is exactly, both of them are exactly the same. There's no difference at all. You can either represent by just simply 234, or you can say represent the same angle by negative 126. Now let's check that question. I need 126 and the magnitude of my vectors should be 13.6. Okay, I need to check the both, because in the simulator it not allow you to put anywhere on this arrow that always should go the crossing point of two lines. Okay, because of that, the sum of numbers are restricted. We can't really have any numbers as we wish in our real drawing graph, the graph sheet. Okay, so I need to change this 126 and 13.6. So let's take a look. $39. You need to just move around this arrowhead little bit to see which one is actually matching up. Okay, one should be match up correctly. Not every number which will gonna match. Okay, some numbers will not gonna match at all. 13.6 and 120. There is that 126. Okay, very good. So this location, in terms of coordinates, you can identify that x should be negative 12, y should be negative 2. That's the coordinate for the arrowhead of the second one. Magnitude 13.6, direction 126 degree angle. That is same as 234 positive angle. Now that is your vector diagram. Question. Okay, to get the result, again the same thing. You just need to click on the sum. Then new vector will appear. Now we know resultant should be the line connecting the origin and the very end point of our vector diagram. That means right here. So let's check whether this can fit exactly on that space. If that fit, that's going to be the right result. See that? that exact fit is actually tell you that is the right resultant. Magnitude is 12.2. Magnitude is 12.2, but the angle it gives as a negative angle that we usually don't like. You know what to do to get the positive angle. Add 360. So you have equal sign minus 170.5. Then if you add 360, then you will get the positive angle. The positive angle for this vector should be 189.5. That's the angle we would like to report. Usually, we reporting angle from the positive x-axis. Positive x-axis and then rotation towards the positive y2. Okay, that's usually the angle should be. Okay, question. All right, then let's continue. Let's take a screenshot of this one. And that's the one earlier I mentioned. I put only 2 space here, but you have to make the space as you needed, right? So I'm going to add that screenshot here. So you need all of those screenshots. Those are actually real data if you actually do this in class setting, okay? Because those are your real diagrams. That part of the data set actually if you're doing in class settings. So let's crop this out. Okay. So that's our figure number 3, and then you need to name it accordingly. Okay, that's my figure 1, and then accordingly make sure that is figure number 3, and then this is tail to head method for case B. Okay, you have to really name it properly. This is for case B, first 2 for case A, and then you can add that accordingly. C, and then this one also for case A. Okay, question. All right, now let's take a look how to do the parallelogram method for this one. Now, if you want to do the parallelogram method for same this case, you can't really have 3 vectors. So that is a problem. We can have only 2 vectors. Keep that in mind, okay? Parallelogram methods only work with 2 vectors. So which means what I can do, instead of previous 2 vectors, I can use the resultant vector to represent both of these 2 vectors, right? So I can use the resultant from previous plus the new vector. Then I have still 2 vectors, okay? That's the plan. Now third vector is already there. All I need is the resultant vector from the previous, right? So let's get rid of this sum. We don't need that. And also you can get rid of these vectors. Instead of resetting the simulator, just click and drag those unnecessary lines to the corner. Those will disappear. And then you can leave this vector as it is. This is the third vector. We need that, okay? And now I need the, instead of first 2 vectors, resultant of those 2. If you remember that resultant, that should be 9.8 and then 114 degrees, right? So let's draw that. Let's bring another vector. That should be 9.8 in degrees and then 140, 9.8 in magnitude, 114 in degrees. So that is the resultant of previous 2. Now this vector technically representing 2 vectors at the same time, okay? See that? Because of that, I don't need actually those 2 vectors at all. Now I have one vector from the origin And if you know parallelogram method, always all the vectors must draw from the origin. So which means this is my third vector that must go starting from origin and on third quadrant. That's why I leave it like that. Otherwise, it's going to take time to exactly figure out that angle and magnitude. If you leave it, now it is easy. Now I have two vectors again. Both are starting from the origin. Any question? Now you can try to complete the parallelogram for this one. Try to complete that. Okay, question? All right, so let's complete the parallelogram then. So which means I have to draw a line end of the first vector which must be parallel to this line. So if you're drawing this in class, it's gonna take a time to draw that. But since we're doing this virtually now, it is very easy. All we need to do, identify that direction right here, see that, and then extend that line. So that orange line there represent exact parallel line to 13.6 this vector, okay? And then I need one more line which is exactly should be similar to the first line and should start from the end of the second vector and then go other side, and then we need to find the crossing point of these two lines. Now I have two parallel lines right here. These two are one and then these two are another one. So parallelogram is actually result of two parallel lines, two set of parallel lines crossing each other. Question. And if I have a parallelogram, the resultant vector, you can click on this sum now, blue line, and you can see resultant vector exactly now showing you the connection between the origin and the next point right here, that is our diagonal. And if this is correct, that should exactly fit to the diagonal, right? See that? So that's the idea of the resultant vector from the parallelogram. It's exactly the same result like earlier, 12.2, 12.2, but the angle it show negative angle. I need to correct that. Okay, let's correct that in a bit. But the magnitude 12.2 and the angle it shows you negative, which we don't like. If you have any negative angle, if you want to correct it in positive direction, in this case, what we have to do, equal sign minus 170.5 plus 360. I need the angle from the other side. So then you will get exact angle you got earlier. Okay, that's our result for the parallelogram method, case 2. Question. Okay, then let's continue. Let's take a screenshot of this one. So these are actually going to be part of your data if it is in class setting. Because of that, let's bring that picture here, insert screenshot inside your left hand side. You can select the pictures And you can take the screenshot very different ways. Okay, you don't need to necessarily do how I show you here. And there are various different ways to get the screenshot on your computer. If you know any method, just follow that. Nothing to worry. Okay, don't need to do exactly what I suggesting here. You have freedom to do that anyway. And crop the picture out, and that's our figure number 4. This is for actually parallelogram case B. Parallelogram, but this is for case B. And then likewise, as you continue, collect those figures. Okay. All right, question. Okay, let's then try the last one. So let's see how to do the 4 vectors, right? Now, in terms of 4 vectors, I can keep these 2 vectors here because we need them. I can get rid of this one. Sum you need, unclick that. And then these orange line you need, click and drag, and then you can get rid of them. You can keep these 2 because this is actually third vector. This is the resultant that also I don't need actually. What I need is the first 2 vectors. Let's get rid of that too, but this we can use as it is. That is the third vector. Now let's draw tail to head method. Tail to head method is starting with the first vector always. First vector is starting from the origin. Angle should be 35.5, magnitude should be 8.6. That's first vector. And second vector at the end of the first vector, that's what the tail to head means, right? Tail to head means first vector go from tail to head. Second vector is starting from there and then go again tail to head and then so on. This should be 160 and 11.7. Okay, that is the second vector. Anybody have any difficulty drawing this? This should not be as I think, but if you have any difficulty, always ask, okay? Don't try to just observe and then try to do afterward. That technically you're just wasting a lot of time. Instead, you can actually complete everything during the class time, okay? All right, now the third vector should start end of the second, and then it should be 126 negative. Remember, we figured that out earlier. Third vector can represent either by positive 234 or negative 126. So this is third vector 13.6, negative 126. Vector number 1, vector number 2, vector number 3. Now we have a fourth vector, right? Fourth vector is 7.1, 315 positive. So let's take a look. Now this vector should be 315 means should be on fourth quadrant, should be look like that. But the vector should start from end of the third vector and then should go towards the fourth quadrant. However, problem with the simulator, it doesn't show you positive angle, it actually show you negative angle. So like I did earlier, I need to find what is the negative angle to represent 315. So that angle gonna be negative 45 degrees. If you get 315 and then minus 360, then you will get negative 45-degree angle. Okay? So that is exactly same as the previous angle. Okay. So which means this vector either I can represent 7.1 positive 315 or 7.1 negative 45. Both going to be the same. Okay, question? All right, then let's arrange this one. I need 7.1 and then 45, right? So see where it is. 45. 45 negative, but magnitude should be 7.1. Okay, so that shows negative 45 from horizontal line and then magnitude 7.1. So that is our fourth vector. Now you can see likewise, if you have like 10 vectors, you can draw that diagram, right? Each vector after the previous, each new vector after the previous, and then so on. You complete the diagram. That is actually called the tail to head method. Then the resultant will be always very final point to the very initial point, which means if you click the sum here, that should show you a vector which should be able to connect very starting point, the beginning point, which is the origin, to the very end point. So that is our resultant vector. Dark blue line is the resultant vector. Okay. And that magnitude 9.9, direction is negative 135, magnitude 9.9, direction negative 135, which we don't like, so which means equal sign minus 135 plus 360, because we like to have the other angle. Okay, direction from the positive side, so in terms of positive magnitude, that should be 225. Okay? Leave it there and then take the screenshot. And that screenshot also you can add after this one. Insert, add pictures, and the screenshot. Crop that out. Any unnecessary space. We don't need any other information. We just need that graph. Okay. Right. So that is our fifth figure. Now this should be actually KC triangular. This tail to head method sometimes called the triangular, but that has a little bit of different meaning. Okay. This is figure number 5, and then this is for KC. Figure 4, previous one. Make sure you numbers those properly. Okay, equation. Okay, then let's see how we're gonna do the same one by using the graphical method 2, which is parallelogram. Again, the idea of the parallelogram is that you can use only two vectors. So which means you can use only result of last tree and the new vector, right? So to do that, I'm going to get rid of this sum here, we don't need. And first two vectors, actually first three vectors we don't need, right? So which we need is actually result of first three vectors. So let's identify that first. If you remember, result of first three vectors is actually this guy. 12.2, negative 170, right? So let's keep that and then get rid of all the other vectors. Don't reset the whole thing, because otherwise it's going to take some time to identify where's the direction and magnitude of these vectors. Okay? This is our vector, result vector of previous tree. So that is actually right here. Result of previous tree. So that's going to be 12.2 in magnitude, positive 189.5, negative 170.5 degree angle. Now what I'm going to do, I can use only two, right? Parallelogram method. So I'm going to use resultant from previous tree, starting from the origin, and starting from the origin, fourth vector. That's my two vectors now for the last diagram. Result from the last tree, first three vectors, and the new vector that is a fourth vector. Now I'm going to build again the parallelogram, right? You know how to build the parallelogram. What we need is one line exactly parallel to vector, and that should go from end of the other vector, and another line parallel to exactly the other vector, which should start from the end of the previous vector, and then wherever these two cross, and then you identify the diagonal from the origin, that should be the result of these blue vectors. So to check that, all you need to do, click the blue color icon here, sum. If it is the right vector, you can see that exactly match with the diagonal space. If you're doing this in class, this is going to take a while to draw because you have to draw all of these lines, and then you have to measure this space by using the meter ruler, and then you have to measure this total angle by using the protractor. So all of those going to be taking a lot of time, but this way it is actually much easier than that. Question. Magnitude of the resultant 9.9. Direction, you can see the simulator gives you the negative, but we don't like that. Equal sign, minus 135 plus 306. So that's the positive angle we would like to see, right? So you have to have always a positive angle to represent the vector. Nothing wrong. Represent the vector with the negative angle. Nothing wrong. It's the same idea, but we would like to always use the positive angle. Okay. Okay, that's our table number one. So one last thing we need on that table is this diagram, right? This graph. Take a screenshot. That will be our sixth graph right here. Insert pictures and crop that out. Okay, so that's our sixth graph, the sixth figure, and that should be for KC, but parallelogram. Okay, you have to name it properly. That is sixth figure, figure number 6, and this is for KC. Okay, question. Question. No question? Then which means that is very easy. Okay. So then let's continue. Let's start now analytical method. That's where you need a lot of work actually. So let's take a look how to do the analytical method. We're going to take a look both methods. And on the table 3 is just a percentage error comparison. Okay, that's not really anything complicated to do, but the table number 2 is very important because that has a lot of calculation. Okay, let's take a look. Now, to do that, we need to get the idea of two different things. The component method, I think most of you have a good idea because we use that in our lecture class many times now. But the cosine sine rules, we did not use much, but I think we use at least one time during the chapter number 2. Let's take a look that again today. Okay, that's the plan. So let's see what we have. If we have a vectors, let's say if I have two vectors like vector A and B, if I draw that into a tail to head method, then the resultant vector is R, right? So which means if you know the two vectors in this triangle, by using cosine and sine rule, you can find the vector R and also you can find the vector theta. That's what we're going to do. Always to do the cosine sine rule, you have to have only two vectors. That's again important. Like for the parallelogram method, you can't do cosine sine rule more than two vectors. But component method, you can do any number of vectors. That's the difference there. Okay. Let's take a look at the case number 1. Question. We are on now table number 2 and about cosine sine rule. So let's take a look case A. I have two vectors, vector f1 and vector f2. And go into that table. Vector f2. I want to do this by using the cosine sine rule. Okay. Now to do that, what you need is actually small diagonal. Now this is not to scale. Okay, you don't need to scale. You don't need to really measure anything. This is just a sketch. So you just need to sketch here. So which means let's draw a small sketch. X-axis, y-axis, and the first vector is starting from origin always. That is our vector f1, and the angle, this angle gonna be, let's say, theta 1. That we know theta 1 is 35.5. Now your vector number 2 should start from here and then should go this direction, that is vector number 2, and this total angle should be theta 2. Now the idea, this is look like the, worry about drawing it to the right scale or anything. You just need look like that scale picture earlier. This is just a sketch. Okay, if you have a sketch, now if you take a look this sketch, you can see this should be the resultant, right? That is the resultant. That is R. And the angle of the resultant should be this angle, right? Because we would like to measure that from positive x. Now we need to find that R first, right? And also we would like to find that theta. Now to do that, you can do this easier, because if you take a look this triangle, you have a triangle look like this. One leg is F1, other one is F2, other one is R. Now you know if you have a triangle with 3 legs, and then if you know at least one angle here, let's say this angle is A, then I can do the cosine rule. What cosine rule tells you, R is equal f1 square plus f2 square minus 2f1 f2 cosine angle in front of the line R, and then parentheses square root of that. Now these are known, right? f1 is given, f2 given, and 2 is a constant. All I need to figure out is this one. If I figure out that angle A, then I can simply solve this one, and then I have the idea. That's how easy the mechanics of these methods are, instead of drawing, right? So we're not going to draw anything here. All drawings we do here is actually just to visualize the problem. Now again, cosine sine rule can have only two vectors. You can't do anything more than that, because that must complete a triangle. So you apply this rule for a triangle. That's the idea. Question. Okay, then let's take a look how to figure out that angle. Now you can see this is theta1. Because of that, this is small angle right here. This is small angle right here should be theta1. Because this line crossing the two parallel line, then the angle in Z kind of shape in your geometry class some long time ago, this angle should be the same. And this part right here, on the other hand, I can say 180 minus theta2. So technically, I can say angle A, which is equal 180 minus theta2 plus theta1. So you know all the numbers, then you can easily figure this out. So 180 minus theta2 is 160 plus theta1 is 35.5. 180 minus 160, 20 plus 35.5, which is about 55.5 degrees. So that is angle A. Now I know angle A, which means I can do this calculation. So I can find the R very easily. Now these are actually useful, okay? Unlike the drawing method, which we done earlier with the simulator, that really not anything useful for our lecture class. We're not going to draw anything, right? But all the calculation we do in here, this can be a part of your lecture class too, because all the calculation you should know how to do them. Question. Okay, then let's take a look how to find the angle. Now I need to find this angle right here, right? That blue line right here. Now to find that blue line, let's see how we're going to do that. To find the blue line, let me draw that again. This blue line, okay? Let's say that blue line is theta. I need to find that. You can see I can't find it very easily. However, if you have a triangle, there's another law we can use that actually called the sine rule. So if this angle is A, let's say this angle is B, this angle is C. So the sine rule tells you the ratio between the lines and the angles inside, right? So if I apply the sine rule for here, then I can say sine B over F2 angle and then divide by the leg in front of that angle. Okay? That's the ratio, which is equal angle of sine A divided by R. And then similarly, this is equal actually sine C over F1. But I can use only these two to figure out A, right? So figure out B. That is the angle we interested, this angle, right? Because if I know that this part right here gonna be B, this angle right here B, then I can say angle theta, which is equal angle B plus angle theta 1. So theta 1 is already we know. Only thing we need to find is the B. If I know that, then I know the angle of the result. That's the plan. Now I can do that easily finding this B here. That B gonna be equal sine inverse parentheses cross multiply F2 over R. We're considering only these two, okay? And sine of A close brackets. That is angle B. If I know angle B, I can say angle theta of the resultant, which is equal angle B plus theta 1. So that's the idea. Then I know magnitude and the angle, both of them of the resultant. Okay, question. Now let's do this by using our Excel sheet. Okay, now you can do this calculation with the calculator. That is not our plan. Our plan is always to do this by using the Excel sheet, right? Let's try to do this by using our Excel sheet. Table number 2, I want to do the R here. Okay, let's do that function. Equal sign, square root, that means SQRT, square root, open brackets. You have to remember that equation, right? Equation, let me go back there. There's equation right here. F1 square, F2 square minus F1, F2 times 2 times cosine A. Cosine A is 55.5. Okay, so let's type that here. Square root F1 is 8.6 to the power 2 plus F2 is 11.7 to the power 2 minus open brackets 2 times F1 8.6 F2 11.7 times cosine. Now there is a problem with the Excel. Excel always read only radian values. It cannot really read degrees. Because of that, anything you have in degrees on the table, you have to make sure you give that in radians. So in your Excel, there's a radian function, parentheses after cosine. You can write the radian function. You can see that radians, okay? Radians. I need that angle A 55.5, but in radian. You can manually convert that. That's okay. That's one way to do it. But since I do the Excel, I would like to do as a single function. Okay. And then close bracket for cosine, close outer brackets for the after negative sign. There should be another outer brackets, and then there should be another last outer brackets for the square root. Then hit enter button. If I do the calculation correctly, I should get the previous answer 9.8. Because we done that graphically, now you can see I getting the exactly same answer. So let me copy paste that function. Now I'm going to collect all the function here. Okay, function 1, this is for table number 2. Okay, table 2, all the function we're going to collect here. This is for the function case A, case A function R. Okay, case A, and function for R. I'm going to leave it here. I need to copy that again. Let me copy that whole function, and then as you continue, just collect that function. Okay, copy and then paste somewhere else. Let's paste it to here. Okay, so that's our function for the cosine sine rule. Function for the cosine sine rule to calculate the R. Any question so far? You have to be very careful when you do this function. Anything missing, any parentheses, anything missing, you're not going to get the answer correctly. And also, what I want you to do, when you do your report, let me show you. I show actually one report so far, done fairly good standard. Nothing else, only one report. Okay, just one report. I see fairly good standard. Let me show you that report. That might be useful for other people. Then you can compare. Some of you can identify where you are on compared to that report. Okay. So this is a very good report done by one of your colleague, Michael Giraratana. So he actually done a pretty good job. So let's see what he doing here. Okay. You see that report, right? Okay, let's see. He had the front page objective and theory physical principle. He don't copy paste anything. Actually, he wrote everything. Therefore, there's no anything directly identified, but he wrote all the equation which we actually using in class. If he don't use any equation, he actually add this last equation, which is not important, but there's no point reduction if you add those things. But if you don't use any formula, you don't need to add them. Any equation, if you're doing there, you have to name it, right? So you can see this parentheses and then he naming everything. And then he doing the citation by using the IEEE format. Just you don't type the author's name or anything, just a number. Then you call that number in your reference list, okay? Then you can see apparatus. Most of the people for this lab, only 2 words. There's no apparatus. There are going to be huge point reduction for those people. But unlike those people, this guy done actually 1 page of procedure. So that how that is possible? 90% of the class, when it comes to this part, there's only 2 words. There's no procedure, but only 1 student can do 1 page. So that's I was curious to understand really. If I really physically there, then I'm gonna ask you individually what you thought about it. You need to think, right? So you can't just go blindly. You need to think what we're doing here. Data set is given, yes, but what really am I doing? I'm using Microsoft Excel to do the calculation. So your Microsoft Excel is actually one of the apparatus for that case. You have to think. You need to get practice thinking. If you not get practice thinking, then really I don't know where you are going. So that will be a problem. Okay, this class. Remember, I'm telling this very very seriously. The reason this class is not just the class you go and sit and then going to pass. Okay, you need to really understand. You work hard, you will get a better grade. You don't work hard, you have to spend maybe 50 hours for this class. I don't care. You work hard and then try to maintain the status, keep it up with the class phase. Then you will get a better grade. Otherwise, there's no chance getting a better grade in this class. This is not a class like I don't know. I don't like to compare to any other subject, but you just go and sit down and then, listen to the instructor and then have a discussion with your colleague and then have fun and then pass the class. This is unfortunately not like that. This is a very challenging class for many students. Each semester we see like lot of trouble for students. That's why we try to give you a lot of resources, and even giving that resources, some people don't see that. I don't know what to do really, because I see some people never tested or checked that sample report. Some reports are extremely poor. All right, now let's see. He explained what he done in each table, for example here, okay? And then he has the table nicely done, and he show a little bit of work, and then all the tables he nicely done, and all the equation done. Table naming is good, and all the final table, and all the graphs he included here, graph renaming, and all done nicely. And then he write it down, the discussion and the references, and you can see number format, and the reference should follow IEEE format scale. All of this information they are on the sample report. Even I will add this also as a sample report. Then you can see one of your colleague done the same way up to that standard. Then you can learn from that. Okay, there's nothing wrong really learning from that. And then post-class quizzes in pre-class quizzes. And then at the end, this is what I want to show you. Now this one nobody done really. Either some of you not really doing Excel calculation, or maybe you don't know how to do Excel calculation, or maybe you don't care how to do Excel calculation. I don't know, but I don't care any of those things. This has to be included every single lab moving forward. So this is the only student who actually identify what to do by thinking himself. That's really, really big deal, okay? Really big deal. You can see he naming every single function. That exactly what you're supposed to do. Tell that function what it does, and then rename it as an equation. Then call that equation in your discussion section if it is needed. Okay, but I would strongly suggest every one of you actually take this report and then take a look. Okay, then you can learn from there. Then actually some of you can realize your report should get actually 0 point, even though I gave those report like maybe I don't know, 30, 40, 50, but those are not really the report to earn any single point compared to the standard what we're looking for. Okay, so please take a look. This is not really telling like anybody can't do this. This is telling everybody can do this if you really start thinking carefully. Okay, you can't really blindly go here. You have to really think carefully what I'm really doing. If you have a question, reach out and ask. That's why we have a lot of help. That's why we have SI session. That's why we have tutoring center. That's why we try to help you guys. But you have to talk. You have to reach out and ask. Any question?
Yes, Professor.
What's up?
Um, so I think I misunderstood you when you were explaining it before. Um, and for my, let's see, data tables and analysis, instead of putting the tables into that section, I put it into Appendix C and quoted out of it.
No, no, no. Tables should be on the data section. And these tables are not appendix. Appendixes are anything extra. That's why I show you. You take a look that report later. Okay, I will add that into our Moodle page. Okay. So appendixes are extra work, not the data or anything. Like the Michael collected out all the function which we use in the class, and then he put as appendix C. That's what the appendix mean. Okay. So that's okay. We are still in the beginning of the semester. I'm not telling anybody, you can't do this. I'm really trying to show you what you're supposed to do, and then try to tell you you can still improve. There's a time, okay? But every semester we see this, we tell like millions of time, but some students are not really listening, or maybe I don't know, not care at all. I can't answer those things. But take a look, and then you have to really get into that, okay? So, all right, now in your Moodle page, already there's 2 sample report. I will add the third one. This your own class report that will be useful then. Then you can really understand what this report's supposed to be. Okay, then you can actually start making better and then high standard report as we go moving forward. Usually at the end of the semester, reports becomes very short and then easy. um, just first few reports are usually challenging. That's very normal in this class. Okay, but try to spend a fair amount of time there. You can really catch up, I think. Anyone else has any question?
Professor, for when we do the Excel functions, you said in my report that we don't have to repeat the same function, like for average deviation, there's like 10 of them. How do we?
Need to, yeah, you need to repeat only. If it is the same function repeating, you have to add only one.
So how would we just write the first one and write that we did this, through like whatever, F10 or?
Right, yeah. Or you can put that into a appendix C and then call that in your discussion. Both are correct.
Okay.
Yeah.
All right, thank you.
Yeah, that's fine. Anyone else has any question? It's still early in the semester. You have a lot of time to improve. Okay, nothing much to worry. I saw a couple of reports might get lower grade. We're gonna drop the one lowest grade anyway, which means if you have one lower grade, nothing much to worry at this point. Okay, one other thing I would because I spent time in actually discussing that the lab grade is something. Some point every one of you can get 100 there, because if you do the lab report up to a certain standard, then you can get 90 plus without any problem. If you're not getting, only problem is that you're not doing the report up to the standard, but it should be, okay? You have to think very carefully and then go back and then check with the sample report and then reach out to me and then ask what went wrong, why you telling this, what I should do here, and then so on. Then I will explain you. Then you can improve accordingly, okay? All right, so let's continue. Anyone else has any question? Okay, so now let's do, we done one calculation. Now you can see, now you can collect that function. See, you can't say just KSA and R, you saw that earlier report, right? He wrote it down, right? What the function is really doing. So you can explain that little bit in just like 1 or 2 words, okay? And just simply here, for example, this is cosine rule apply into case A to find the R. So that's good enough. And in terms of sig figs, I can't have this many sig figs, right? How many sig fig I can have? Sig figs, depending on how many number of significant figures in my given data. So in this case, only 3. So I should convert this, reformat, right click on the cell, format cell.
Professor, you're not sharing your screen.
Yeah, I can't see your
Oh,
scene.
sorry. Yeah, sorry. I think I did not share after previously. Yeah, sorry about it. Let's start that. Okay, now it should be good, right?
Yes, sir.
Okay. Yeah, so let's continue. Now, what I was talking earlier is that you can collect the function like this and then write one or two small words to represent what that function is doing, okay? And then let's see, now we have R here, but we can't have this many sig figs. So let's reformat that. Right click on that cell, format cell, and then numbers, and then I can go one number and two decimal, then I can easily get 3 sig fig, right? So let's enter that, and then if I do that way, previously, since I'm measuring directly from the simulator, I can't really add any more significant figures there because simulator show me only that. Because of that, we wrote that, right? Because whatever we saw directly, we wrote only that. That rounding. Because of that rounding, you will see a little bit of error. Otherwise, technically, this is going to be exact, perfect match because we're doing calculation with the numbers, simulate. They're also doing the same thing internally. Okay, but if you do this part is specifically table number 1 with real in-class graphing. That's something either you guys is going to be missing this semester. That gonna take a lot of time, and also this number gonna be fairly off, considerably off. Like you can get 10.1, 9.5, various different numbers depending on how precisely you draw. Because of that, we're going to see fairly considerable error sometime. That's okay. All right, so let's continue. Now I need to calculate the theta. You know, we discussed earlier to calculate the theta. Let me go back to that function. Right here now, you know theta should be b plus theta 1. Let's first calculate the b and then add theta 1. Okay, so which mean right here, I would suggest you can unmerge this cell. There's actually 3 different cells here. If you click on that cell and unmerge, then you can see 3 different cells. Let's calculate the B, angle B somewhere here. And then let's do B plus theta 1 to get the theta here on the top cell. Okay, let's calculate the B here first. Let's unmerge this one too. I'm going to calculate B here. And then theta 1 you can add on here. You can edit those things, it's not really big difficult. And theta 1 is 35.5, and then we know we need to add 35.5 and b to get theta here. Okay, that's the plan. That's what we understood earlier by looking at that diagram. Sine inverse f2 sine a over r. Now I have to do sine inverse function here equal sign. Now in our Excel always it giving out also the radians. So which means total result I have to convert into degrees. So I need to have first degrees function here. Degrees parentheses sine inverse is arc sine. If you type AS, it will give you a sine. So that's the arc sine. Another bracket open. Now I need f2 over r. Okay, remember the function f2 over r sine a. So let's do f2, which is 11.7 multiplied by sine of a angle is 55.5. Sine of a, when you do the sine function, you remember in Excel, it need radians. So I have to convert into radians, sine radians, another brackets, 55.5, close brackets. Then another close brackets outside, that for radian. I don't need actually this inner brackets, so it's already there. I have extra bracket here. You don't need that. You need only one bracket. There are outer bracket for the side. Then you can divide this whole thing by R. R is 9.8. And then close that brackets. And I should close one more time. Okay, question. And then if all fine, then you should get the arc sine of that angle, which should be equal to the previous. However, let's take a look what angle which I got earlier. 114. So I'm getting 78 here because 114 gonna come after I add these two together. Okay, let's check that. Equal sine theta 1 plus b about 113.99. So that's close enough. 114 I'm expecting. If I round it, you will get exact number, right? So let's round this into 3 sig figs, two numbers and one decimal place. Let's round this into 3 sig figs. If I round that into 3 sig fig, you will get exact number actually. 114. Okay, question. Now let's pick that function also, this function. So let's add that here. That is actually case A. Case A, theta. You can just start theta there. That's okay, I think. That's the function we need. And then we can reformat a little bit to see that clearly. Okay. Question. Okay, now that is actually our case A, cosine sine rule. We need to do the component method for the same one. Now, component method, on the other hand, is actually, anybody have any problem, difficulty doing this functions? Anybody have any difficulty with that? Everybody okay with that? Can manage?
Could you show how you merge the cells again? I'm having trouble with that.
Oh, that's, you just need to unmerge. So
Oh, you unmerge.
Yeah, so if you want to, because there was like 3 cells here, I just merged it earlier, I unmerged them.
Oh, I see.
Yeah, click again the same thing, merge and center, it will unmerge.
Thank you.
Yeah. Okay, so we can take a quick break here, I think. Yeah, let's take a quick break and then let's try this function, okay, yourself, and then ask any question. Let's take about like 10 minutes and then we'll start. Any questions so far? This lab is actually not really anything we're doing in terms of apparatus or anything, even in the in-class setting. It's a lot of calculation. After we basically draw these first few graphs in the graph sheet, everything else is just a calculation, okay? So the same thing we're doing here. Let's take a look how to do the component, right? Now the same exact case, but let's see how to do the component. Okay, to do the components, so what we need? So I need to identify all the components, right? If you want to do the component method, always you draw a diagram. First, to visualize the problem is still the case A. Case A, now I try to do the component method. I'm gonna visualize the problem. So which means let's draw a diagram. X-axis, Y-axis. I have a vector here, vector F1, theta 1, angle, and then I have a vector here, vector F2. Then this total angle right here should be theta 2, right? So now component means what? The projection, right? So I need to first identify the projection. This diagram later in the semester, now after actually from next week, actually, when we start the Newtonian mechanics, this diagram is so important, okay, extremely important, which we're going to call it as a free body diagram. So that diagram is one of the most important thing to solve the Newtonian mechanics problem. Okay. So now let's see, that means all the vectors should draw from the origin. So let's see now. Then I'm going to draw another diagram which is going to show only component or the projection. So I have vector f1 that should have a component or the projection here, f1 cosine theta. Then I have vector f2 component or the projection should be there, f2 cosine theta. Vector f1 should have a projection here, f1 sine theta. Vector f2 have a projection there, f2 sine theta. Now those are the projection, right? So which mean all the projection are now xy direction. So technically this should give us one resultant vector on x direction, one resultant vector on y direction, right? If I add all the x together, you will get 1. Depending on which one larger, it can be negative or positive, doesn't matter, okay? And then depending on the x, the y component, both are positive, I will definitely got positive resultant upward, which means final resultant vector gonna be total x square plus total y square root. That is Pythagoras law we use in class many times. So that is something we will need again. And the angle of this are going to be theta. That's going to be inverse tan y component over x component. Now total x component going to be f1 cosine theta 1 plus f2 cosine theta 2. I treat this as a vectors. Okay, when you do this theta 2, you will actually get a negative sign for this one. That is negative. That negative sign will appear with the large angle you're getting from positive x direction. You don't need to add another negative sign here, okay? And then y component gonna be f1 sine theta 1 plus f2 sine theta 2. Now let's do this in our Excel sheet. That's all really. So let's go to Excel sheet and then let's do x component equal sign f1 8.6. I think it's better to use a parenthesis here. 8.6 times cosine angle. You know I have to do the degree or the radians actually. Otherwise, this will give me a wrong answer. Radians angle gonna be 35.5. Close bracket. Close brackets again. And then close brackets again for the outer brackets. Okay. Then plus open brackets. Then I need f2 cosine theta 11.7 multiplied by cosine open brackets radians and angle going to be 160 close brackets again close outer brackets. Hit enter. Now that is our x component. You can see I'm adding both vectors, but my answer is negative. Reason, my second vector is larger or negative direction. So this is still case A. Oops. Okay, so let's see, copy paste that. You can collect this function as you go on. That will be actually useful. Still case A. Now this is xnet. Okay. You can see I'm adding both vectors together, but however, negative sign appear because of this, right? You know 160 cosine should be negative direction. That automatically becomes negative. That is larger. As a result of that, this result is now negative direction. Let's do y component equal sign. Exactly same thing, but technically only cosine has to change the sign. You can either type again new, or you can copy paste this function into here, and then you can change cosine into sine. So that's another way to do it, because exactly same thing, but what is changing is cosine into sine. That should be a positive number. We copy paste that function also. Here, this is y net. Case A is still okay. That is y net, and then let's do result question. Everybody okay with that function? Still we are working on case A, okay? Okay, let's do Pythagoras equal sign x square root x qrt parentheses x to the power 2. You can just, instead of typing the number, click that cell and then close bracket. We don't need actually close bracket. You can do automatically plus sign because the function will work fine. Other cell power 2 and then close bracket. If you even do another parenthesis here, that's okay. But even without that, it's working fine because you can immediately see that's the same result which I'm expecting. Okay, question.
Professor, can you show how you got the y net again, please?
Right here. Okay, any other questions? All right. Anyone? No problems? Okay, so let us continue then, right? Good. Okay. So let us see how to get the theta here. Equal sign. I need arctan, but remember the Excel automatically give you the radian value. I need to convert into degrees. So that means I have to put the degrees command here and then arctan, atan, right? Arctan. And then I need y versus x, sorry, y divided by x. So this is y component over x component net, okay? Close brackets, then close outer brackets for the degrees. Okay, now there's a problem. It says negative 66. So why it is negative 66? What should I do? So that we need to take a look, right? So we done it correctly, but it says negative 66. Your vector is actually right here. That's the resultant, okay? Resultant of vector 1 and 2. And then I'm expecting it actually this angle, okay? We know this angle should be 114, right? We calculated that earlier. That should be 114. That's what we're expecting. Instead, is actually what you're getting is this angle. That's the negative angle. That's negative theta. That negative theta, we need to correct. How to correct the negative theta? This is the same line, right? So that's the same line. To correct that, you have to add 180 for that one. So if you add 180 for this, then I will get the right angle. Okay, see that? So you need to correct that properly. Let me copy that function also. So this is for theta, for xy method or the component method. Theta. And you have to add that 180 because I need to have the positive angle, not the negative angle. Okay? That's the component method. If you don't do that correction, then you will see nothing wrong. Negative angle always has a equal and positive angle. You can actually represent that any way you like. Doesn't matter because as far as it's on the same line, see, that's the same vector. That vector angle you can say relative to x, positive x-axis has a positive angle or relative to negative direction. That nothing wrong really. But the standard way is actually what we're telling is whereas the direction is relative to positive x. So you have to write it correctly, then only it representing this arrow direction. Arrow direction comes always relative to positive direction. That's why. Okay, question. Okay, then let's take a look now. You can see there's a lot of significant figures here. There's not really much meaningful. So I should change this into maybe, let's see, 2 decimal places, right? If I do that, that will be 3 sig fig, but this one I have to go back to 3 sig fig, which means without any decimal places. Right here. Okay, then reformat the cells to about 3 sig figures. Not really meaningful having more than 3. Okay, good. Any other question? Or you asking the resultant here, this one, right? Sorry, I think I did not copy that function. So let's copy that too. Let's add here r is equal that. That's a resultant function, okay. Okay, so let's take a look the other next one. So what happens if I have 3 vectors? Now you know in cosine sine rule we can't really do 3 vectors, but we can do only 2 vectors at a time, right? So that will be a problem. We have to take care of that first. So let's take a look how to do that. Now this is case B. If we have 3 vectors, I can't use 3 vectors. Because of that, what we're going to do, I'm going to use result of the previous vector plus the third one, okay? Now the result of the previous vector, 9.8, magnitude, angle is 114. So let's draw that first. So I'm going to draw that diagram here. I have a first vector here. That is actually result from the previous two, 1 and 2. This total angle is 114 degrees. And then magnitude we know 9.8, okay, Newton. And then end of that, we're going to draw the third vector. Third vector is 234 and then 13.6. Now that should be on this direction. Now this is vector 3. And then angle right here, this total angle is actually 200. Let me erase this one and then put it here. Somewhere here, this is R12. And then this angle is 234 degrees. Okay. Now that's the 2 vectors we're going to use, R12 and F3. Now resultant of this 2 going to be actually this one. You remember earlier drawing method, we identify that now this is the new resultant of vector 1, 2 and 3. The subscript I put 1, 2, 3 to represent this is the resultant of vector 1, 2, 3 now. But in cosine sine rule, as I should have only 2, right? That's why I did that. So I need to find now this guy, right? To find that, you can use the same trick again. You have a diagram here. You have a small triangle here, look like this. This is R12. This is R123. This one is f of 3. Now I can find R123, you know, I know this guy, I know this guy, then I can square them, but I need this angle right here, right? If I find that one, then I have the answer. So I just need this angle, let's say angle A. Exact same process we done earlier. I need to find this angle. Now how to do that? This total angle is 114. So which means if I go here, this total angle should be 114. Same exact thing we done earlier. This is 234. This part only right here, 180. So which means this is small piece. This is small part right here is 234 minus 180. That means 54. Which means angle A now. These are geometry, okay? These are not physics or anything. I don't know which class you took. Usually grade 9 or grade 10, okay? You should take that. So the all of this should be done years ago, but you need that information, right? So that means angle A right here, which is 114 minus 54. So that means about 60 degrees. So that's the problem with the physics time now. If you don't remember that part, that will be difficult to proceed the problem. So that's where the physics problem becomes so some students sometimes reason of sometimes the background knowledge, not the physics. Okay. Now I know A, I know F1 and R12. I can find the R of 1, 2, 3, which is equal F3 to the power 2 plus R of 1, 2 to the power 2 minus twice F3 R of 1, 2 cosine A parentheses square root of that. And to find the angle, I would like to know what is this angle right here. Now this will be the total angle we interested, right? That will be our theta for the new R. But I can find it easily because this part is half of that is 114 exactly. So the rest is actually this part right here. So let's say that angle is B. Then you can do the same thing you done earlier, which means sine B over F3. This part gonna be now B, which is equal sine A over R1, 2, 3. So from there you can find the B, which is equal sine inverse F3 over R of 1, 2, 3 times the sine A. Sine A we already know, right? And to find the real angle theta, then you have to do this extra calculation. Theta going to be equal B plus 114. So I have to do that part. Then I have the theta or the angle for the R1, 2, 3. That's the cosine method for the case 2. Question. You need to really spend time on these things, really, okay? How much time you spend actually decide your grade. That's what is actually guaranteed over the years. That's what we have seen. The student is spending not really time is spending me not really watching videos or attending SI or going to the tutoring center. That itself doesn't enough. What you have to do this yourself, not watching someone else doing, okay? You have to really rewrite. If you go to SI, work yourself, rewrite yourself with the SI. If you go into tutoring center, work yourself with the tutor. Don't just watch the tutor explaining you. That does not help you at all. And then we see that every semester some student is spending a lot of time with watching videos and then no results at the end. The reason is that it will not give you the skill you needed. Instead, actually, you just watch video like you watching the movie. There's no difference. Someone else plays the game and then you just the observer, like we watching the football. That not give you anything unless you really sit down and then walk this through. All of this information in this lab, all of this work, you have to write it down yourself and then include into appendix C. Okay, then I can see whether you really done yourself or not. I really don't care. Even you can watch this. I will upload this. By watching this, you can rewrite yourself. That will help you to gain little bit of knowledge. Okay. That's what we done when we small. We write it down everything. We don't have a videos or anything. We write it down many times. Because of that, all the information by the time end of the year, we actually remembers. We don't need the textbook to take a look. we don't really depending on anything. We are just free from everything. We just need our brain and the pencil and pen and the paper. Now, in your generation, brain and pencil and pen, the paper doesn't help. You need a computer and social media or something else to search and answer the question. Not everybody, some of you, okay? So that's what we see every semester. So that's very unfortunate situation where we're going in the future, next 150, 100 or 50 or 100 years, then we will see the effect really. Okay, so let's see where we are now. So we have the cosine sine rule done. Let's apply that. Okay, let's apply that here. Now you know how to do this, right? Equal sign, square root, sqrt, open sqrt, open bracket. Make sure when you do the function, don't really type the function. Instead, select the function here. Then if something missing in our writing, that will be corrected automatically. Be careful with that, okay? Square root, and then I need the function, what? F3 square plus R1, 2 square. F3 is 13.6 to the power 2 plus R1 of 2. You already have that answer 9.84, right? 9.84 to the power 2 minus open brackets 2 times 13.6 multiplied by 9.84 times. Now I need cosine. Cosine, open brackets, we need the radian function always in Excel. To do any trig function, we need that radian function. And then angle is A. We figure out that angle right here, A, which is about 60 degrees. Okay. 60 degrees, so which means 60 here, close brackets, close outer brackets, then another brackets. I think I should have to have another bracket for square root. Equal sign 12.16. Let's take a look. The answer we got earlier, 12.2. So if you rounded that 12.16, then you will get exact answer. Let me copy paste that function into here. Now we are working on case B. Case B now for the cosine sine rule R. Okay, can say just cosine sine rule and then R of that, and then that's the answer for that, or the function for that. Okay. All right, question. Okay, so let's continue. Now we need to do angle, right? If we go into the angle, then there was a problem because I can't find the angle directly. I first need to find B, then add 114, right? So let's see, I think, get rid of this couple of cells here. There are extra cells. Unmerge that, and then let's calculate B first, okay? Okay, then let's do B here. B is equal sign. I need the degrees because always this will give me the radian value degrees, then arc sine, A of sine, arc sine, open brackets, F3 13.6 multiplied by sine of A. Remember that function, okay? Sine of A is 60 degrees. Sine, open brackets, I need radian function there, and then 60 degrees, close brackets, close bracket for sine, and then divide by R123, that is this number, 12.16. 12.16, close brackets, and then close another bracket for degrees. Then you will get 75.59. That's not the answer we're looking into. Answer we expecting to be 189. Now to get that, I need to add the 114 degrees for that, okay? Let's add that. So equal sign, this number plus 114. So I'm getting 189.599. So we expecting 189.5. So we are close. And let me write it down here. Theta is actually equal to B angle plus 114. Then you have all the information there. Okay, question. And also there's too many significant figures. Make sure you actually reformat all of these. In between doesn't matter. These numbers, you can even leave it like that. Those are doesn't matter, but our final answer has to have the right sequence, right? So let's reformat that maybe to like 12.1. So I can't have even 4. I can go only 3. If I go 3, then I will get exact number. So that's the problem with actually this, because at the end, we will look like have the perfect result. But remember, when you do percentage error, I will show you in a bit. When you do percentage error, you have to really calculate. Don't just put 0 there. Even now, for example, when I comparing, this is 12.2. This is also 12.2. But internally, you have other all the other significant figures actually they are in that cell because it's a calculated cell. When you do the percentage error, you will see a number. Okay, don't just put 0. We need to really do that calculation. Let's take a look in a bit. Okay. All right. So let's see next one. Question. Okay, so I will let you to collect the function now. I'm not longer collecting the function. After we do this part, the last part I will show you in writing in other pad. But that functions you have to try yourself. Okay, because I would like to get like about 15 minutes to discuss about the exam and then quickly go over the very brief summary too. Let's take a look the component method for this one. Component method, now still case B. Case B component method. To do the component method, you can have any vectors, any number of vectors, doesn't matter. First, draw the diagram. Later in the semester, this diagram I mentioned earlier, this diagram is actually going to call the free body diagram, which is extremely useful. X-axis, Y-axis, all the vectors is starting from the origin, okay, in this diagram. First vector, F1, angle theta 1. Second vector, F2, F2, angle theta 2. Third vector, F3, angle theta 3. Now let's identify all the component. X-axis, Y-axis. First vector has a component here, F1, cosine theta 1. And it has a component here, F1, sine theta 1. Second vector has a component here, F2, cosine theta 2. It has a component here, F2, sine theta 2. Third vector has a component here, F3, sine theta 3. And then it has a component here, F3, cosine theta 3. Now you can see there's a 6 component, and then if you get the add all of in the same line and all of in the same x line and y line, then you will get the resultant on x direction, resultant y direction. I don't know which direction now, depending on what is larger. And then you will get the resultant, which is x square plus y square root theta is arctan y over x. If you take a look, this x now adding all of those components, which mean f1 cosine theta 1 plus f2 cosine theta 2 plus f3 cosine theta 3, then y should be f1 sine theta 1 plus f2 sine theta 2 plus f3 sine theta 3. Now keep remember this. Now when you go into next, last one, only difference is that you have these three and then last one come here, F4 cosine, last one come here, F4 sine. So the component method actually very straightforward and easy. Okay, so let's check that. Okay, so I think you can do that function. Okay, I'm gonna let you do that function. Instead, I will talk about this cosine sine rule for next one. That will be useful. Then if we get extra 15 to 20 minutes, we can actually take a look the exam and then last 4 chapters, little bit like very brief summary. Okay, we don't have a lot of time to go over, but let's discuss very briefly. So I would suggest you to try this and then have any question, always reach out. Okay, it's the same way. You have a function here already, cosine sine. The only addition is that there's a new term. Okay, if you go into this part right here, the third vector cos component adding up, this one third vector sine component adding up, and then you can do exactly the same way you done the rest. Okay. So I would let you to try that. If you can't finish that for tonight before midnight, then you can actually submit the data table without that. That's okay. Okay, that's nothing to worry. Since all of these we're going to be skipping, you can actually submit without that if you can't manage it. But make sure lab report, all of them should be completed. Okay, that you have a week. So let's take a look the case C, sine cosine rule. Anybody have a question? I think you can manage that easily, but anybody have a difficulty with that cosine xy component for the case B? Can manage? And also one other thing I forgot, that if this theta, you need to be careful, right? If this theta becomes negative, that you always need to check. Okay, remember, if this theta becomes negative, then always do this one. You have to add 180 plus theta to get the right positive angle. Okay, so that always keep that in mind too. Otherwise you might feel that I have a wrong answer. It may not be the wrong answer, it's going to be just a negative direction. Let's take a look case C instead. That will be very useful to take a look how we're going to use the cosine sine rule. Now, cosine sine rule, you can have only two vectors. Okay, you can't have more than two, which means I have to bring the result of my previous, right? Result of 1, 2, 3 vectors plus the last one. That's the plan. Okay, so which means I'm going to draw it here. Now what we're drawing is actually result of 1, 2, 3 is this one. That is 12.2, 189 degrees angle. Okay, so which means x-axis, y-axis, that is actually look like that. That is result of 1, 2, 3, and this total angle is 189.5.6 actually. 59 or 0.6. Now last vector I'm going to add from there, F4 7.1 315, that we can add from there now. Now this is F4 and then theta 3. Theta 3 is actually you are measuring from here. This total angle, that total angle is 315. This part right here is actually 45. Because that's important, because I would like to find this inner angle always, right? Now, which means your final resultant is actually this one. You can compare this with your graphical method. This is actually resultant from 1, 2, 3, 4. Resultant of all 4. If you take a look, that diagram is actually look like this. This is F of 4. This is R of 1, 2, 3. Now this one is R of 1, 2, 3, 4. Now let's take a look. If I want to find this R of 1, 2, 3, 4, you remember we always need this angle A. So let's take a look how we're going to find that one. This is 189.50. This part right here, 180. So which means this small angle right here is actually 9.59 or 9.6. Which means this part right here is the same angle, 9.59. So which means simply angle A, which is equal 45 degree plus 9.59. Okay, 45 point plus 9.59 mean 54.59, right? Or 54.6 roughly. Good question. Anybody have any question? Okay, so which mean I can do the cosine sine rule, which mean R 1, 2, 3, 4 is equal R 1, 2, 3 to the power 2 plus f of 4 to the power 2 minus twice R 1, 2, 3 f of 4 cosine A parentheses square root. We done exactly same function earlier. Carefully take a look the previous line, what you calculated, then bring that function to the next part and then make sure you adjust everything. Then you should have the right answer. How to check whether your answer is correct or wrong? Go to the table number 1. You should get exactly same number. If not, we're doing something incorrect. Okay. Always check here and also your function. Okay. Also, I need to get the angle, right? So the angle of this new resultant is actually this total angle. That is the theta, because always relative to x, right? Now this part right here to here, we already know. Here to this part is 180, and then here to all the way to this, we already know 189.59. So which means technically I just need to find this angle. So let's say that angle is B. If I know B, then you can say angle theta is equal B plus 189.59. So all you need to find is the B. To find the B, you can use the sine rule. So same thing, sine of B divided by line in front of that, which is F4, is equal sine of A, line in front of that R 1, 2, 3, 4. So which means B is equal sine inverse parentheses F4 divided by R of 1, 2, 3, 4 and sine of A. Be careful with those functions when you're writing on the Excel, because it has to be certain way. Since we already done 2 of them, it should not be difficult at all to do. But again, that is not the real theta what we're looking for. To get the real theta, you have to do this addition again. Okay, then you will get the right answer. Question. Okay, let's take a look very briefly the cosine and the component method also for last case C. Then I can add the slide whenever you need, you can refer them, case C, but the component method, right? So now you have 4 vectors. So let's draw all 4 vectors, x, y, vector 1, f1, theta 1, vector 2, f2, theta 2, vector 3, f3, theta 3, vector 4, f4, theta 4. Now you know the process, right? So we would like to have all the component, x-axis, y-axis. I have here f1, cosine theta 1, and then I'm going to get another component here, f4 cosine theta 4 from this one, and then here I have f1 sine theta 1, another component from 2, f2 sine theta 2, then I have here f2 cosine theta 2, another component here f3 cosine theta 3, here f4 sine theta 4, another here f3, let me write it down on this side, f3, that's better, easy to understand, f3 sine theta 3, f4 sine theta 4. Now you have 4 components on each axis, so which means again the same process. So I have to find the resultant x and y, and then eventually you will get 1x and then 1y. Then your r going to be equal x square plus y square root, and then theta is arctan y over x. Okay, let me write it down, the total x and total y. This is going to be then f1 cosine theta 1 plus f2 cosine theta 2 plus f3 cosine theta 3 plus f4 cosine theta 4. So that's what I mean earlier. Until this point, we actually done earlier until this 3. Then you adding the fourth one, okay? And then similarly, y gonna be f1 sine theta 1 f2 sine theta 2 plus f3 sine theta 3 plus f4 sine theta 4. Now, technically, now when it goes to this function on your Excel sheet, technically the second layer we done after you finish the second line, is case B, most of the function you have there, okay? You just need to carefully copy paste that function into new cell and then do the adjustment carefully, okay? So that's all you have to do. If you do that, then you can easily actually do this calculation. So I will let you to do that calculation. Okay, so all of these I will highlight it here, which means this you have to do it yourself. And if you have difficulty uh, before tonight midnight, don't worry about too much. Just leave it those three empty. Submit the data sheet. Okay, data sheet has to be submitted before midnight, and then complete all of those for next week lab report. Then at that time, if you have any question, you can reach out and ask. Okay, question.
So for the lab report for this one, we're not going to be using table 3 at all, right?
No, table 3 you have to do. I'm gonna explain right now.
Oh,
This nothing to do there. This is percentage different. Let me show you how to do it. Now, what you need to do on the table 3, I'm not going to do anything on the table 3, okay? That also you can skip for today's data sheet, but you have to complete for lab report. Now, what you're doing there? Comparing, right? TD, analytical 1, analytical 2. So what you're comparing PD between these two. So you can see it look like 0, but you can't write it 0. The reason, since I did the calculation, all the numbers are inside there. So that where the problem comes. If you do with the calculator, you can't really compare these two at all. You will see it as a 0. That is wrong. You have to do the calculation. Let me show you now. If you want to do analytical 1 and 2 here, equal sign, ABS, parentheses, difference between analytical 1 and 2. Analytical 1 minus analytical 2. Don't type the number. Just click on that cell, close brackets, divide by PD means you have to divide by the average. So which means divide by double parentheses, this guy plus the other guy, divide by 2, close brackets, multiplied by 100. If you do that, you will see a number, but that number is almost very close to 0. You can see it e to the power negative 14. 10 to the power negative 14. You can't do such kind of a calculation with the calculator. So that's the idea of computational methods. You can take a look whether there's a possibility of very long decimal number have a small difference. There is, okay? You have to really do that calculation, okay? Let me copy paste that function also. This is table 3. Let me copy paste a little bit below here. Table 3, case A, case A, and R. Okay, now let's do one more calculation for theta also. Then you have all sort of different calculation done. So then you have to do the same thing for graphical 1 and analytical 1. That is actually this result right here, 9.8 versus analytical method 1, this result, okay? That should go here. And then you have to do graphical 1 and analytical 2. So which means this 9.8 versus this 9.84. Technically, you will not see anything much different between these two answers, okay? But you have to really do that calculation. That will not only giving you how to do this calculation, that actually gives you the lot of a good experience with the function on the Excel. So you will gain mastery of those function, use of those function, things like that. That's the other skill development during this kind of work, okay? It's not just really doing physics or math, but you have to really gain a little bit of more than that. Okay, so can you guys do that? This table can skip for the today's table data sheet submission, but you need to really complete everything by next week. If you have any difficulty, always reach out and ask. Okay, I can show you one or two calculation maybe next week during end of the lecture class, or maybe end of the lab class next week, if you have any difficulty. Okay, good, no question. Anybody have any question there? Can you manage that? There's nothing new, just doing the percentage difference. Remember, we're doing percentage different, okay, not the error. Comparing two numbers, denominator should be always the average, okay? Right here, denominator should be always the average. Make sure appropriate parentheses and things like that. Okay, any question? Okay, so what I would like to do is that do a quick review of what we're trying to do on this exam coming up. So that may be useful actually. So that's the plan, okay? Let's see. Any question?